Hello. Look, it's me, the p5.js editor. Wait, no, that's not me. I'm Sam. This is the p5.js editor up here. Um, Hopefully my face is in focus. It looks fine. Okay. I think it doesn't autofocus when I start my camera thing. You guys, this is a whole mess of software making this whole streaming setup possible, and it's running on a lovely two-core dual core with hyper-threading Intel CPU from 15 years ago. So shout out. Could be running on my M3 MacBook Pro, but it's not. So, so you get a solid two cores that are pretending to be four cores, but really, let's be honest, they're just two cores and they're not very fast. But let's see what we can do with this. Okay, I want to do. I guess let's probably keep it in a functional style, right? So let's do a flower, right? What is a flower if a flower was a function, right? Let's do function flower, and it takes probably an X and a Y and a stem length and maybe a petal count and maybe a color. Or petal color. This color is reserved. And maybe an angle. Which should actually, this should be. See, I really need to learn like the Vim shortcuts or something like that. Oh, that's fine. I don't want to log in just yet. Oh gosh, see, I'm streaming sleepy these days. I need to stop doing that. So let's also make this a little bit larger. See how big that is. Okay, and let's make this. Let's see, red, green, blue. 150, 150, 240. That's probably like a sky blue kind of color, right? A little more purpley. That's okay. I can adjust. Probably less red. Yeah, that's pretty sky blue. Mm, Yeah, there we go. That's kind of a good color. That's what I want. Um, so yeah, I guess okay, let's do this. Let's do this. So let's put some music on my VLC. Let me put that on the other window. Oh, it is on the other window. Thank you, Katie. You know exactly what I want, except for when you don't, in which case that's really frustrating. Streaming. So, okay, let's just draw. Let's draw a flower, right? And so we'll start it at halfway on the screen, on the bottom of the screen, because in p5.js, higher y values go down and higher x values go to the right. Just to fuck with you. And the angle, I guess let's do like standard calculus angles. It'll start at the right and it'll move, what's that? Counterclockwise? Yeah, counterclockwise until 2 pi. So vertical would be half pi, which I believe is a constant, yes. And stem length, let's see, our screen is 400, so we'll just hard code this. 380, that's 280. So like a little bit below the halfway point of the screen. That'll count, let's say 8. I see another variable. petal length. Let's give them 40. I don't know how big that is, but we'll find out and we'll adjust it. And petal color, let's say, let's go with that purple color we had earlier. What was that? 150, 150, 200? That was like a purpley kind of color. That was a fun color. I liked that purple color. Hopefully nobody's colorblind. I don't know how the contrast is on that, but I think it's probably fine. Yeah, that's probably, the contrast is fine. Yeah. So also many years of coding in P5 and processing. You just gotta have those RGB colors memorized. You know, if you think about it, it's just the same as the like Photoshop color wheel. You're just editing the numbers directly, and also that would be hue, saturation, value, and not RGB. So it's like not exactly a one-to-one comparison, but you know, you can imagine as you have more value, right? All of the colors shift towards the top end of the range. You have lower value, they shift towards the bottom end of the range. So you have like, if all of your colors are in 0 to 50, that's a very dark color. If all of your colors are in 200 to 255, that's a very bright color, right? Because each channel goes from 0 to 255. And then your saturation is how far apart the different colors are, because in neutral gray, all of the channels are exactly the same, right? The red, green, and blue are exactly the same. And so if you make the channels more differentiated, it's a more saturated color. And if you bring the channels closer together, it's a less saturated color. So you can sort of translate all of these things in your head into the RGB values. And that's how I can just look at it and type up a new color. And you also, you know, think about just color mixing in general, because it's, you know, you have red, green, and blue. So it's like if you want to make something yellow, you want red and green, right? And it's color mixing in terms of light, not in terms of what we usually think of, which is in terms of absorption, like pigments, when you mix pigments, which is why the colors are red, green, and blue and not cyan, magenta, yellow. Because that's having the channel red, green, and blue versus not absorbing red, green, or blue. So I guess if yellow in light is red and green, then yellow is just absorbing blue, right? So the yellow ink is absorbing blue, whereas yellow on a screen is emitting red and green. And then you go into biology of the eye, and that's a whole other, that'll be a class for another day. But right now, you know, let's say I wanted to make this, let's actually just comment this out and make this purple color we had from earlier. Right? And so this is that purple color we had from earlier. And let's say we wanted this actually to be a little less saturated. So let's bring these two colors up by 10 and this color down by 10. So what I'm doing is I'm just bringing all of the colors closer together. And that's not really exactly how an average would work, but just, you know, napkin math. And see, now it's more gray. And let's say we want to make it brighter. So let's just add 40 to all of these colors, because if you change all channels, that's brightness. All channels moving together is a brightness change or a value change. Channels moving closer together or farther apart in terms of like deviation or distance from each other is saturation. And channels moving independently, just one channel at a time, is hue. So yeah, I added 40 to the other two, so this would be what, 230? And so this color, when I hit this play button, this should be the same exact purple, but about 40 ticks lighter. And we see that it is. And I actually like this color, but it would require the sky to be darker. But that is no worry, because what if the sky... what color should the sky be? I guess actually maybe the sky should just be even brighter, so there's still a little bit of contrast there. So let's just bring all of these colors up. And obviously you can't go brighter than 255 because that is the brightest color that the sRGB spectrum supports, which is the same computer display spectrum for most computers. Some computers are fancy, but most computers just have 0 to 255 colors in each channel. So let's also add stem color. I'm going to see if I can... Is this okay in JavaScript if I do this? Yes, of course it is. JavaScript, you can do anything, even if it's a bad idea. So we'll have position, or I guess we'll call this anchoring, because this is where like the bottom of the flower is going to grow from. And then this is stem settings, and these are the petal settings. Okay. And so I guess first we'd want, okay, so we'll also want stem width. So, okay, petal. I guess actually, let's just do a stroke. And I'm putting an F underscore because stroke width is a function. And the reason I'm doing this is because I could do a center of the flower. I don't know, what is that called? I don't know. Let's look up what the center of a flower is called. Oh, parts of a flower diagram. Who's M and H? Are they trustworthy? American Museum of Natural History? Oh, I suppose they're probably pretty trustworthy. So I guess it is the stigma. Yeah, because this is like inside of the flower. Okay. Stigma. I wonder if there was a better diagram. Jeez. Well, see, this is saying it's the pistil. Oh, the pistil contains the stigma, the style, and the ovary. So it's the pistil of the flower. Hopefully I'm saying that right. I'm not trained in Latin. But yeah, I don't want to draw the pistil because I'm lazy. So we'll see. And I also am going to have to look up how to do a Bezier curve, and we'll find out what that is together later. But for now, let's do the stem. So let's say stroke. So first of all, you know, p5.js, you have fill and stroke. So we're not going to be using fill here. We'll say no fill, and then we'll say stroke. And when you say stroke, you're defining a color of stroke. Should be called stroke color, but it's not. That's okay. And so because we're drawing this stem, and I did not put a stem color. Oh, and see, now I've got this. I wonder, does JavaScript support naming parameters? Let's ask the robots. Okay. We could do object destructuring. Okay, this is good. This is good. Flower. So yeah, let's do object destructuring because then I can name everything. And so we'll say const and put those same parameters we had here. And this is a destructuring assignment. So we might, for example, demonstrate destructuring like this, right? So let's say we have A is 1, B is 2, C is 3, right? And wow, I somehow managed to do different spacing on all of those. And so let's assign my var. Okay, so that didn't work. But let's just say that we have this, right? We have this. It's an object in JavaScript, which is similar to a dictionary in Python. It's complicated. But this is, we call this an object in JavaScript, which means different things in other languages, but this is JavaScript. So if you want to learn other languages, go somewhere else. And so this is an object, right? And let's say we want to get, so okay, I guess, can I assign and print in the same thing? I can. Okay, yeah. So let's say we're assigning a constant, right? So you have let to define something that is variable, meaning that it can change. And you have const for a constant, meaning you cannot change it, which might cause me problems in just a second when I try to redefine a. But let's say a equals this object, right? And then let's log a, and here we go. Now we see a has a equals 1, b equals 2, c equals 3. Great, right? But let's say we want a to actually be 1, just like in our object. Well, we can surround this assignment with the same syntax, those little curly brackets, as you would normally do in an object. And it's basically saying, we're assigning an object, but let's pull out the variables that are living inside of this object, and that's called destructuring. And so now when I run this, A is going to go and take that object which we are assigning on the right side of the equation, and it's going to look at the parameters of it. It's going to say, okay, what is the parameter named A, which is the name that we're calling here, right? And it's going to pull out the value and assign that to the variable A. So it's basically like unwrapping it like a present and finding all the little goodies inside. And so instead of logging the entire object like it did before, this should just log the value, which should be 1. And there you go, it logs 1 to the console. So that's great. And the reason I want to do this is because I have so many goddamn variables, pardon my French, that I want them to have names over here where we call our flower, because the idea is this is not going to be the only place where we're going to call a flower. We're going to try and expand this more in a minute. But let's, now that we have this destructuring, we can actually define what all of these variables are. We can say the x and the y and wait. Yeah, xy angle is half pi. And then, okay, 380 was the stem length. And then 8 was the petal count. And see how now I have the name of the thing next to the value we're giving to it, which is important because it means that not only do I have, a more clear representation of what these things are, which I could have another way with a comment, right? Adding a comment to say what that is. But now it's explicitly defined in the code, and so we keep that name with us wherever we go, right? Which is useful. And then I guess I'll also change this f stroke width, and let's call it pen width. And so it was 40. This 40 was the petal length. And the color was the petal color. Okay, and let's also, so see, now we have a couple more. And so XY angles, so we're missing pen width here. And, we don't have to put that here. We could put that here. Though, of course, it's going to complain at me because I haven't got a comma. And this is why you might see, you might find it a bit odd that there's so many trailing commas, because usually in English, we don't put commas at the end of a list of items, we put a period, right? And in programming, usually you just put nothing at all. But the reason there's so many trailing commas everywhere is because then, if I leave this comma here and I add something new, I can immediately start typing, and then it's not going to give me an error, right? Because that value is named. And then additionally, we get the benefit of being able to shuffle these around, right? And we can put these at the end, and we can move the lines around, and it's no big deal because everything has a comma at the end of it. So it knows that that's, the end of the list, or an item in the list, depending on where we move it. And it stays valid. So cool. Useful little syntax. So, okay, we've got X, Y, angle, pen width, stem length, stem width, stem color. So let's organize this in our own little way up here. And stem width, we'll call it 3. Actually, the stem width can just be the pen width, so we don't need that. And then all we need is the stem color. And let's just make a green color. And if you remember, red, green, blue. So if we want a pure green, let's do that, except that's probably a very bright green. And it's a very saturated green. So how do we make it less saturated? Well, we bring these up, and we bring this middle one down, so all of the channels are closer together. How do we make it darker? Well, we bring each channel down by a similar amount. So let's do 40. Sort of eyeballing percentages, because really you don't want to bring them all up or down by a fixed value. Really, you want to bring them up or down by a percentage, because then each channel scales at the same rate instead of just moving in the same direction by the same amount, which is not necessarily the same scale from 0 to 255, right? So I think this is probably roughly a dark unsaturated green color, like the stem of a flower. And so now let's actually draw the flower, which is what we came here to do. And so the first thing we'll do is a line, right? And so we've got, in a line, we start at a position and we draw to a position. And so the position we're starting at will just simply be XY. And then the position we're finishing at will be X plus some value and Y plus some value. So we're going to have to use the good old sine and cosine, and sine is the Y and cosine is the X. And I think I should just be able to plug these in because we use the good old trig circle, right, where it's starting on the right and it's going counterclockwise to 2 pi. So it should just automatically understand the angles there. And then we'll just multiply that, because obviously these functions have to do with the unit circle, getting the x and y of a certain angle on the unit circle. And the unit circle has a radius of 1. So if we want to draw out a certain length, we can just multiply those values to the length that we desire. So that length will be stem length. And I've been coding for a little bit here and I haven't hit the play button yet. So hopefully, if all goes well, something will show up on the screen. Drum roll, please. And we've got nothing. Okay, let's see. Object arguments is not a valid color representation. Oh, because I didn't put the stroke, which should be the stem color. So I didn't put an argument there. And so now it should be no fill. Oh, we also should put stroke weight to define that, to set that up for the next thing that we draw. And the stroke weight is pen width. Great. All right, it's not the direction that I was hoping it would be, which is odd because I'm using angle, A-N-G-L-E, angle. So I guess does it not start where I think it starts? Okay. And so what is 2 pi? Let me pull up a unit circle. I might just be misremembering this. It's entirely possible. Okay, that's not it. There we go. This is it. Yeah, so 2 pi should be back here. And this should be xy should be the value of the result of cosine and the value of the result of sine. So half pi should be vertical. And you know what the problem is? X, Y, X and Y. First of all, we've got these switched around. Should be cosine and sine. And also, p5.js actually has positive y values pointing down, so we need to invert the sine function. And there we go. Now we have a valid flower stem pointing up as we expected. Okay, great. So, yeah, do a little bit of math, sort that out. And then let's actually, let's extract a variable here and do a little refactoring and say const pedal equals, and then let's actually call this pedal pause. And let's put the x and y definitions here. And once again, we will do that object thing where we assign the fields of an object to equal this value. And so then in here, you can do pedalpause.x, pedalpause.y, and let's actually, can you rename? No, you can't. Let's call this the pistil because now we know what that part of the flower is called. And I'll put a little comment here for the non-botanist like me looking at this code later. Say the pistil is the center of the structure that lays the center of the petals in a flower. Because we looked that up earlier. Okay, and I'm going to move this stroke down here, so then we have sort of a clear separation between the upper half being data and the lower half being drawing. So, okay, no fill stroke weight, stroke line. Everything still works. Everything still works. Good. And so now let's do the pedals. So, okay. First, let's just get a for loop, right? So it's for let I equal 0. It's probably a familiar structure if you've done any other programming, and if it's not, I'm sure there are many tutorials on Khan Academy or something where you can find out what this loop does, and I'll explain it briefly. And so let I less than pedal count I plus plus. And so what this loop is basically doing is it's going to count from 0 to 1 before the pedal count, and then it's going to stop because it's less than. If it was less than or equals, then it would get up to equal to the pedal count, so it would be from 0 to 8. But we actually want it to be from 0 to 7. And the reason we want it to be from 0 to 7 is because we want to start at 0, and we sort of want 8, the 8th pedal, to wrap around and touch 0 where the beginning of the first pedal starts. And so I also I also want to do, so first, okay, first here's what I want to map out, right? First, I want to map out the petals as spokes, and I want the spokes to specifically be where the petal starts and where the petal ends. So let's just do petal start equals this, and we'll do this other object structure, and give them 2 values. And so we'll do the same kind of math, but instead of starting at the base of the flower, we're going to start up here. And we've saved that earlier in pistil pause. So we do that, .x, and then actually even just copy this, put it here, and then we add pistil pause .x, because x and y are just the ones defined up here, which are for the whole flower. So yeah, yep. Okay. So let's do a little mapper function, right? So we're going around the flower, and we want the this mapper function, which, so okay, doing calculus, pre-calc, trigonometry, going all the way back to trigonometry. We want to start, realistically, I want to start at the bottom of the flower, because I think if you have an odd number of petals, they should split, sort of forming that angle at the bottom of the petal and then sort of meet at the top. And so this is going to map from, so if if the unit circle is going from 0 to 2 pi, right, and we want it to be on a continuous line circling around the flower, we want to actually start before 0. And you could say that pointing down is pi and half pi plus half pi, which is true. Pointing down is pi plus half pi, but it's also rotating backwards by half pi. So we could say negative half pi, and then when we rotate all the way around coming back down, it will be pi plus half pi. And I just got rid of so many parentheses. How many do I need? Just the 2 and then a comma. Okay. And so this is the range we want to map to, right? And so the value we want to map is I, and I we know goes from 0 to 7, but I'm actually going to say 8 here because this is the start of the petal, right? So I actually don't want it to ever get to 8, because that's going to be the end of the last petal, right? So we'll do I again from 0 to 8. Actually, let's just copy this whole thing, because this is just the angle of this line that we're drawing. And no, it's not, because that's where the angle variable is. This is the length of the line that we're drawing, which should actually be petal length, which we have above. So I'm going to go put that in here. Okay, and so hopefully when we run this, we should see blink, 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 blink all the way around the flower, and we should see 8 of them. And we see none of them because I haven't drawn any lines yet. So let's do a line from, and I'm just going to make this, I'm just going to make these like a special color just for right now. So I'm going to make the starting ones green. So RGB, RG is green. I'm going to make them like a fully really saturated green just for visualization purposes. And yeah, so Yeah, so, okay. Sorry, what am I doing? Oh my god, what am I doing? Right, I'm drawing a line. Sorry, I just totally blanked out. I'm drawing a line from. It's really hard to do this and be like talking nonstop the whole time. It's so difficult. You have no idea. And so the line is going to start from the center of the pistil. So pistil pause x, pistil pause dot y, and it's going to go to this new petal start position, which is we're saying was like the spokes of the petals of where they're starting. And we see some petals, and first of all, they're too small, so I'm going to make them 80 long. I'm going to make them 140 long. Much better. Okay, and we see how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 spokes. And this is great. And so now I'm just gonna take this and I'm going to say that the first petal ends where the second petal starts, right? So if I take this exact code and I just copy paste it and I call this petal end, and I take that here and I rename this and I rename that, and I just say I plus 1, and you'll see this is where that 0 to 7 is coming in handy, because now the next one is where we actually hit 8, and the beginning of the next one should actually wrap us back around back to the first one. So the 8th petal is actually the same as the first petal. And so let's make this red. So it's red for end and green for start, just like a stoplight. RGB red, okay. And something is weird. And I think what is weird is that we need to space these out just a little bit. So I'll move the red ones to, well, I'll move the red ones. Wait, it's counterclockwise. Yeah, so I'll move the red ones a little bit clockwise and green ones a little bit counterclockwise. So they should be sort of split apart. And hopefully we'll see, okay, maybe move them more. I don't know if it's gonna work. Yeah, okay, great. So you'll see it starts and it goes around and it stops and it starts and it goes around and stops and it starts and goes around and stops. And so if we draw this petal and we start drawing out and we come back around and go back into the flower and we just do that shape, we've got a flower petal. And so to do that, oh my goodness, now we have to do some math that I do not love. So let's look up the Bezier curve in p5.js. And I'm going to be honest, this is beyond me mathematically because I haven't looked into it, and I'm not researching it right now. But we're just going to draw a curve, and we're going to give it basically the points that we've already created in this sort of spoked wheel, and hopefully it's going to be able to fill in pushing that line out and bringing it back in. I don't know if it's actually going to be able to do that, but that is my hope. um, and so let's see, what is the parameters of a Bezier curve? Okay. So this is the 2D curve. And so it's x1, y1, x2, y2. And so it's okay, so it's anchor, control, control, anchor. And so here is my thought, right? I think what we really want to do is anchor the point in the center of the flower, right? And tell it to go warp all the way out to this thing. So it's going to curve around. And then this second anchor is here, or the second control point, sorry, is here. And so it's going to go all the way over here, and then it's going to come back and anchor at the base of the flower. And I think that's going to look, good. So let's try it. And it's anchor, control, control, anchor. So it should literally be the pistil position, and then the first spoke, the starting spoke, and then the ending spoke, and then the pistil position. So that's anchor, and it's control, so it should kind of push it out, and control, so it should push it back in, and then it should anchor. And what is our pedal color? So let's make this pedal color for the stroke for this part, and I'm gonna leave in the lines just so we can see those. And then we're gonna do Bezier, and just gonna say anchor, control points, second anchor. And so these are just X and Y's. And so again, the two anchor points are going to be the pistil, so it starts and ends at the pistil, and the two control points are just going to be the start and the end. And so we've already calculated all of this, all these lovely little points here. So hopefully, pedal stroke, pedal color. And did I say pedal stroke up here? No, I did not. Okay, I just made that up. Oh my god, it's a flower, you guys! Oh my god. Wow. Okay, so so okay. So you'll notice it's not going as far as those lines are going. So what if we just say pedal length, see, okay, so I want to keep these lines where they are. And then, okay, so let's just duplicate this loop, right? First of all, duplicate this loop. So the original loop is unaffected by the crimes I am about to commit. And so this should, if we just empty this loop out of all of its code, this should theoretically, we should just have those lines. Okay, normal lines for testing lines. And then what if I make a second loop where I just cheat and I just say, let's say the pedal length is, because like looking at that flower, it was like what, like a quarter off. So if we just say pedal length times equals 1.25, and maybe pedal length, which is a constant. And see, this is why you should set things to constants if you don't want them to be changed, so then people can't commit crimes inside of your code. And it's just a little bit off, so I'll just say that's 1.3. And that's pretty much spot on. 1.5. No, that's too big. 1.4. Perfect. And see, now this little circle encloses that flower. And we don't need to worry about this these test lines anymore. We've measured the flower. And we also I can remove this sort of differentiating the lines so that they actually start and end in exactly the same place, and there's not like a little bit of leeway. And there you go, there's our flower. And let's say do 5 petals. And it seems I have hard-coded the petal count. Where have I hard-coded it? Here. And this maps it to 8. Petal count instead of 8. And there you go, 5 petals. We can do 40 petals. See what that looks like. Whoa, that's crazy. It's almost like a dandelion. You can make these white. Now you've got a dandelion. Not exciting. I guess you'd have to make this darker, which we can do by changing all of the channels together once again. So now you've got a dandelion. Oh, that's so fun. Oh, that's so fun. And then and this is really what I wanted to do, is I just wanted 100 of these. So we'll say, and this is sort of P5 inside knowledge, there's this function no loop, because draw usually runs 60 times a second. So if you have some sort of animated thing, which we could actually, I could do, I could say every second the pen gets wider, right? So milliseconds divided by 1,000 is every second. So every second is going to add 1 to the pen width, and you'll see now it's sort of filling in as the frames move on. But if I do this no loop and I run it, you'll notice it doesn't happen because it's not animating it, it's not looping it. So let's put this back. What was it, like 3? Yeah. And so what I really want to do is let's do a for loop here, and let's say let I equals 0, and then I less than 40, and then I plus plus. And we can just make a bunch of flowers, but what if, say, all of the flowers are in a different place? And so let's map, oops. Let's actually, so let's give them sort of an effect of being scaled. So let's say let scale equals, oh, that's already so flower scale equals random. And you'll notice when I see something is bolded, and I'm trying to name a variable after it, I name it a different name. And the reason is because you can override some functions that are already in p5.js, and then you can't use them anywhere else in your code because now they're assigned to your variable instead of the p5.js function. And so let's make this a constant for here. And so the flower scale is going to be random, which is, let's say it's from 0.2 to 1. Let's bound that, because usually random is bounded between 0 and 1. But you can add those numbers, and then it will be bounded between the numbers that you've specified. And so we'll say this y position, or actually, yeah, so the stem length, we'll multiply that by the scale. And the petal length will also multiply that by the scale. And let's just see what that does. So we should have 40, whoa, repeat number, received not a number instead. Oh, yes, because these are not, this is not the scale, that's the other scale. Okay, and see, now we have flowers of all different sizes, but they're all stacked on top of each other. So let's put them in random places on the floor, basically. So from 0 to the width of the screen. So anywhere from this corner to this corner. And you'll see now there's sort of a field of them. And then let's also randomize the number of petals. And so I think I would much prefer fewer petals to more petals, but sometimes if there's more petals, there's a lot more petals. And there's actually a function that sort of follows this pattern called a logarithm. And so I believe if I do this, and also we'll have to do a floor because it's expected that the number of petals is like a solid number. It's an integer. You can't have like 2.5 petals. That would be strange. And so this is, so let's do 40 to like, I don't know, 9 million. How many is that? Okay, yeah. So see, now it's more likely that there's fewer petals, but when there's a lot of petals, there's a lot of petals. And this is kind of fun, but I don't know if that's actually working out for me. So let's just, this is the creative part of the coding. We've just left the math field and just started to play with numbers that feel right in my heart. So maybe there's 10 to 40 petals, and maybe there's actually 5 to 30 petals, and maybe that looks good. Maybe it's actually just 5 to 10 petals, or maybe it's actually 3 to 10 petals. What does that look like? Oh, see, that's kind of fun because some of them are like more of a clover shape. And that's not even starting. Oh, see, I've got to make it an integer. There we go. Now it's sort of all lined up. And I think actually 4 is the lowest I want, because then that's like a 4-leaf clover. Okay, yes. And so the petal color, let's just give them all a random color. So let's just do random 255. And let's just do all of them our random color. And see, that's sort of fun. But what we can also actually do is we can set the color mode to HSV, HSL, HSV, HSL. I don't know what the difference is between all of these. But then you don't even have to do the calculations in your head. You can just have p5.js do them for you. And so hues from 0 to 255, and I believe saturation and lightness are from 1 to 100. But we want pretty saturated, pretty light colors for the petal. So we'll do these from 50 to 100 just to get the upper half of that saturation and lightness. So there's no darker, less saturated colors. And you'll notice that our stems are sort of discolored now, but we can actually have these be a set hue. And I think green is probably, let's see, like Roy G. Biv, right? Red, orange, yellow, green. This is probably right in the middle. It's probably like around 150, maybe. Let's see, is that a green? Okay, that's a green. And then we can change the saturation and the brightness to make more or less saturated petals. I want these to be pretty low. So I'm going to say probably from 20 to 70 on the brightness, and the saturation I'll do from 30 to 80, because I want them to be pretty saturated so you can tell that it's a green. And in fact, I want them to be even more saturated than that and even more bright than that. So there's some darker, no, not that bright. There we go. That's a pretty good spectrum. Well, let's maybe do 35. Because see, this, like these two are a little bit too dark to tell that it's green. Yeah, and so all of these are sort of different greens. And then the flower scale, oh, let's just really go crazy with it. And, maybe you have 4 times the size. No, that's too large. Let's do 3 times the size. Oh, that's exciting. And yeah, this is a good assortment of flowers. And you know what? Just for the background, we can just have a random background. And should it be brighter or darker? What if we just pick sort of what a saturation, so like a lower saturation, more of a pastel, and a brighter color, or a darker color. I don't know. I'm just messing around at this point. Oh, see, this is nice. Oh, this is so interesting. Wow. Maybe there's less flowers. Maybe this is a bit too crowded. That's good. Can I even actually, can you put a fill on a Bezier? Oh my goodness, you can. And so then the flowers are just, oh wow. Or so what if we actually make the stroke, give them like a sort of chalkboard type of outline in white. And there you go. That's a flower sketch. Flower thing. Flower field. And so I guess actually, we can make it loop a little bit. But let's just set the frame rate to 1. We'll do that up here so it only happens once. And then every 1 second, it'll give us new flowers, and we can do one final touch, which is when you press the mouse function, you name a special function mouse pressed. Every time you click the mouse on the screen, it'll do something, and the thing we'll do is make it go into full screen with full screen true. And so when I run this and I click this button, that's not a function, it's lowercase. When I run this and I click this button, it doesn't. Let's see, resize canvas. This is a secret trick. So when you go into full screen, it resizes everything to be the size of the screen. And that's a wrong variable. Is it inner width? Screen width? Not inner width. This is some JavaScript inside baseball. Now we're just, you know, accessing the actual properties from the browser that we've got. Display width. Oh, actually, this is a p5 function. Display height. There we go. Okay, and see, now we've got these flowers, which are full screen on this beautiful canvas behind me. And with that, I think I'm going to say, going to bid adieu.